Well, hello guys. How are you? Happy Thursday. I so hope that you are warmer than I am currently right now. I've heard great, awesome things about you and the things that you did yesterday as far as working, doing what you were asked to do. It is exciting to hear that there was all these students and there was only one incident and only one set of parents I had to text. So that was good. I'd like it to be zero, so let's not have any incidents today. And those of you I heard that were in the room at the time did a very good job of being mature enough to handle the fact that one of your classmates was doing a little bit of struggling, and you did a good job. Okay, I expect that from you, and you're meeting expectations. So keep up the good work. Now remember, when Miss Ayada there, that rules still apply. Gum, headphones, phones, those don't need to be there. Make sure that you're cleaning up after yourselves. You normally do pretty well on that, but if you see any stray paper or pencil on the floor, make sure that you're taking care of that. Make sure that you have, I think, your food and things stay in the box and the container. Only your water needs to be out, no gum or candy. And I think there was one more thing I forgot, but if it comes to me by the end of this video, I will let you know. See, field trip less than 2 weeks away. You should hopefully be getting field trip permission forms soon. Should be today. If it's not, Miss Ayada will let me know, and I'll talk to Dr. Madison to take care of that for us. What else? I feel like I'm forgetting something. Oh, quiz coming up. Quiz Friday. Quiz Friday. So if you need to go back and look at some of the videos, please do that. Okay? Please definitely take the opportunity to do that. It will be open note, but you want to be able to find everything you need. Other than that, I think we're good to go and get started with the lesson because we are on shorelines today. Okay, and shoreline processes. Please keep in mind that when we talk about the shoreline processes, that you need to know the benefits of the shoreline process and the effects and its development. Alright, so you should now have a copy of the PowerPoint. It is a little different than the handout that you have. So the PowerPoint I'm about to go over is different from your handout that you're about to get. So write anything down necessary that you need to write. Alright, so I'll give a few seconds for that to happen, and then we will start on our shoreline processes. Alright guys, so this is your warm-up. Write the letter to a corresponding word. Go ahead and pause the video and give yourselves about 5 minutes to go ahead and take care of that. Okay, so hopefully that was enough time for you to get done. Let's take a look at what our warm-up is. So number 1 says when water vapor changes to liquid. Remember, water vapor is a gaseous form of water, okay? So when a water vapor gas changes to a liquid, then that is going to be condensation. Number 2, water in any form that falls to earth, rain, sleet, snow, hail, all those things are precipitation. Number 3, when the groundwater moves through the land, okay? So it's moving through the land. That is going to be percolation. Number 4, when liquid changes to a water vapor, that means it's warming. Now that it's getting warming, it's evaporating. Okay, so it's evaporation. Number 5, the water that is stored within the ground is called, well, yeah, you guessed it, groundwater. Okay. Number 6, water that is stored, for example, ground, clouds, air, etc. That is water storage. Okay, where we find water storage at. And number 7, water that moves directly along the ground without penetrating. Okay, so it is going to be considered runoff. All right, looks good. Check your answer. See why you missed one or why you got one right. Okay, so looking at shorelines. Now, this is not your first slide that you have. Remember, you might have to copy some things down as we go through it. So that's why I told you at the beginning to keep your notebook handy. Or at least I think I did. Can't remember. But make sure your notebook's handy in case I forgot to tell you that. So for us, what are these forces? First, what's a beach? A beach is when you have the accumulation of sediment found along the side of the shore of a lake or ocean. So normally when we think of beach, we only think about ocean, but that's not true. It can be a lake as well. Now, it says waves along the shoreline are constantly eroding, transporting, and depositing sediments. So eroding is, remember first technically you have weathering, whether it be physical or chemical weathering. Then you have erosion. Erosion means that there is some type of movement happening. Transporting is another term for erosion. And then deposition or depositing. That means after it's been eroded, it's going to have to drop somewhere. Okay? And that's going to be what your definition of deposition is. Now, in your notebook, write down the first bullet. Waves along the shoreline are constantly eroding, transporting, and depositing sediment. All right, you're going to have three types of main factors of forces acting on the shoreline. One is going to be wave impact, the second one is going to be abrasion, and the third one is going to be wave refraction. So with your wave impact, it is the impact of large high-energy waves against the shore. So it's constantly, the water's going in, hitting, coming back out, hitting and coming back out. So that's the wave impact. Think of that water hitting you, what is happening. Now then you have abrasion. Abrasion is the solid and grinding action of rock fragments in the water. And we talked about this when we talked about chemical and physical weathering and how abrasive materials are. I think we used on those Brillo pads as an example when you want to scrub something. That's considered an abrasive material. Okay? So we use that. So think of sandpaper on a rock. You're going to get the same thing basically. So that's what abrasion is. For your notes, copy down wave action, the part in blue, and abrasion, the part in blue. So give yourself a pause, give yourself some time to answer that, and just go on to the next. So here we have wave refraction. And wave refraction is the bending of waves, and it plays an important part of the shoreline process. So because of refraction, wave energy is concentrated against the sides and ends of the headlands that protect into the water, whereas wave action is weakened in the base. Alright, so this is an example when we're looking at wave actions. If you see on the corner, you have the waves, and in the middle you have the waves. In the middle. So you have your two headlands on the sides and your headland part in the middle. So that's what the previous slide was talking to. It's going to hit those parts on the side and in the front different than it's going to hit the part straight ahead. And the reason is because waves aren't really coming straight directly at you. They're coming at an angle. So they're going to get those things that are naturally sticking out. So what is a shoreline? Well, it's the line where your shore starts. Just like when I asked you guys, well, what's groundwater? Water under the ground. This one is literally one of those words that they have. So the shorelines are shaped by waves, tides, and currents by erosion and deposition. So you're thinking, waves? I get tides, maybe not so much, and then currents by erosion and deposition. That's another distinct feature of the shoreline. Okay, so one of the forces also is a type of current that we have, and one is a longshore current. A longshore current is a near-shore current where the water flows parallel to the shore. So kind of side by side is going to be your parallel. Think about parallel lines in math. There are your lines that are side by side. So a longshore current is going to go the same way that the shoreline is. Okay, consider them kind of be one of those side by side. And notice that it says turbulence allows longshore currents to easily move fine suspended sand and to roll larger sand and gravel particles along the bottom. So here we go again. That longshore current is when that water approaches the shore at an angle. I'm looking at your, your picture, okay? Notice how that the longshore current is literally running parallel to the beach. If you look over by beach, okay, you'll start seeing the arrow that's moving downward, curving like a funny S type. That's your longshore current. That's the direction it's flowing. So they cause things to go kind of zigzaggy. Just keep in mind, they're not going straight ahead at you. It goes kind of zigzaggy. So it's going to go from here, and when it goes here, that's going to be considered your swash, and that's considered your backswash. Swash, backswash, swash, backswash. And the reason that is because once things go out, once the water goes out, it has to pull back in. So it's actually pulling back some of that sediment back. So here is just another example picture for the longshore current. Okay, so now we're going to look at depositional features that happen along the shoreline. With your depositional features that are happening along the shoreline, it means where the sediment is deposited. Remember, it is weathering, erosion, and then deposition. So the breakdown of the materials, the movement of the materials, and where those materials are left. So these specific ones for this side are your spits, your bars, and your tombolos. Your spits, think about, sometimes what accidentally comes out your mouth when you're talking. A spit. So a spit is an elongated ridge of sand that projects from the land into the mouth of an adjacent bank. And your mouth, or the mouth of a river, is where the water is coming out of. Okay? So that's an example there. That's why I used mouth and spit. The bay mouth bar is a sandbar that completely crosses a bay. Okay? So it's literally, the bay is, let's say, a roundish type area. A bar of sand that completely covers, completely crosses that bay is what a bay mouth bar is. Think about sand bar, okay? And a tombolo is a ridge of sand that connects an island to the mainland or to another island. Now remember, islands are completely covered by water. That's what an island is. Florida, for example, is not an island because it's only covered by 3 sides. It's a peninsula. So Hawaii would be islands. They're called the Hawaiian Islands because they're completely covered on all sides by water. So that tombolo is going to be a ridge of sand. So we're still working with sand. Notice that all of these are sand that connects the island to the mainland, okay, or to another island. And the mainland would be, well, it's considered one of your islands to be further out into the ocean, so the mainland would be the main part of that. But that's okay, we've got some pictures. So as you can see in your second picture, it shows your spit and your tombolo, okay? That sand part sticking out. And in your fourth picture, you can see your bay mouth bar. And you see more how that current is going sideways, and that current is dragging along the sediment as it goes. Now remember, we talked about what an island is. So you have barrier islands, islands going parallel to the mainland, but are separated. Okay, that mainland is that part more connected to something else. So islands completely covered by water, and think about the word barrier. Okay, they're blocking of some type. Somebody sets a point barrier up. They don't want you going by it. So barriers, a couple things you need to know. Longshore currents will create a spit when a hurricane breaks the spit off from the mainland. So remember that spit's just that elongated part of sand, but if something comes around with enough force and wind, it could break the spit away. 2, wave energy drops sand out of the ocean and forms a sandbar. Continued deposition causes the sandbar to rise out of the ocean and from a barrier island. And form a barrier. And 3, rising sea level causes part of the mainland to break off and form an island. So you have a couple looks at how those barrier islands are formed. Here you have a map of North Carolina and the barrier islands out in North Carolina. So that thin line that you see, okay, got your Cape Hatteras, Cape Lookout, Warsaw on the outside of those. Those are your barrier islands. So that is the coastal part right now that you're looking in North Carolina. Okay, this video is going to be like yesterday. You have to go back and look at this one toward the end. and ways they're trying to save the shoreline in North Carolina because the shoreline in North Carolina is in jeopardy. So there are two ways that you can save the shoreline or stabilize the shoreline, is what they call it, because eventually it's going to wear away because of wind and erosion anyway. But how can you slow down that process and mitigate those circumstances? One way is you can form protective islands. Okay, protective islands, we'll look at some of those groins, jetties, and some other things, and also beach nourishment. Might be something interesting, especially for some of you. How do you protect the beach? Okay, so the first thing we're going to look at is jetties. And these are some type of walls, either made of concrete or boulders, that help block out the sand. And it's blocking out the sand from areas around the channel. Okay? So those areas around the channel are going to be areas where water flows. So you're keeping these jetties are like, when you think about when you open the door, almost, okay, anything on that side of the door is going to be caught, and anything on this side of the door is going to be caught. So that's what it is for sand. It blocks the sand from getting to the waterway. As you can see by the pictures there, you have your jetty set up in picture 1, and 2 shows where you have some erosion that is happening, okay, and it's starting to get that build, is catching all that sand from when the currents are coming in. And then you see the third one a little bit more build up, so they're blocking out that sand. Now, for groin, it works like a jetty does, but it's different from a jetty, so they're very similar. In the groins, okay, you are blocking sand on one side. A jetty blocks sand on both sides, okay? Now, the jetty is to keep the water away from the channels, away from the openings, and a groin is designed to keep the sediment from going down the beach. Okay? So you don't want it going down the beach. You want it to stay as close as possible so there's not a complete washing away of things. And what it ends up doing, like I said, is trapping the sand on that one side, causing erosion only to happen on one side. And there is a simple example of what a groin would look like, or what an actual groin looks like. So keeping that sediment on one side. Now, we talked about seawalls earlier. We talked about seawalls when we talked about tsunamis in the past. Okay? So your seawall is going to be literally between the mainland, or not the mainland, but between the, well, actually, technically it is the mainland. So between the mainland and the ocean is going to be this type of barrier called a seawall. And when powerful waves come in, they don't have as much destruction because on the mainland, because the seawall is there. So what happens is the waves come in and they bounce back, okay? And that protects the structures on the beach area, close to the beach area. So again, when we talked about tsunamis, they had seawalls so that things wouldn't flood, get damaged. I think the one we talked about specifically was in Japan. Anyway, so the problem with this becomes it leads to more erosion, because now when we had this where we had the waves coming in and we had the waves bouncing back, they're bouncing back stronger. Okay, think you ever ran into something? I mean, you ran into it. Okay? You ran into it hard and you kind of bounced back. That's what's happening with the waves. So you're bouncing back with that force. What's happening now is that you have I'll read directly from this one. On this one, it says erosion increases because waves are bounced back with most of their original energy. So when you ran into something and you bounce back kind of with the amount of force, almost the amount of force you walked into it with. So, but this again helps maintain the mainland, and here you just have a little photo of the seawall. Okay, and you can tell where the currents are coming in and where the area of excess erosion is. Now, beach nourishment is pretty interesting. Okay, beach nourishment is where you're thinking, what is nourishment? It's where you got to kind of feed something to keep it healthy. That's what beach nourishment is. But how do you feed the beach, right? So beach nourishment is when an eroded beach is replaced with sand. So they're coming back and they're giving sand back to the beach. Okay, beach nourishment does solve the problem, however, it is very expensive. Okay, as well, beach erosion is still occurring, so it must continually be done. Please pay attention very closely to this slide. All right, you've got some test questions and quiz questions from the slide concerning beach nourishment. Okay, so let's look at the first one. As you look at the first one, notice where the road is. So that part's supposed to be the beach, but notice that the waves have come in so much that you no longer have that area of beach. So now the beach is practically gone and it's right up against the road. So when beach nourishment happened in the second one, second picture, same area, notice how now the beach is further out. Okay, now you actually have a beach to go to. That is what beach nourishment, that's the result of beach nourishment. It's expensive because, well, you got to get the sand. And when you get the sand, you got to have the sand shipped from somewhere. So you have to have a place where you're taking the sand from. It could be another beach, could be another area. And then think about getting it from someone else. So you're buying sand from someone else, and then you have to transport the sand, and then you have to lay out the sand. So it becomes a very expensive process. But again, the problem is solved that now it's not right up against the mainland. So, interesting, pretty much. I do enjoy talking about beach nourishment. All right, and also what happens with beach nourishment is so think about the expense you just costed you. But the problem is with beach nourishment, again, other than it's expensive, guess what's still going to happen no matter what? Erosion. Erosion is still going to happen. So what are they going to have to do a year or two from now? Or not a year or two, but later down the road? Nourish the beach again. Okay. So this is a before and after picture of Miami Beach and the beach nourishment that had to happen at Miami Beach. Okay. Un bonito a Miami. Okay. Would not have been so un bonito. Bonita? Uh-oh. Would not have been so beautiful if it was right up against these buildings. And as you see with those buildings and hotels, they would eventually been destroyed because there's no beach to protect them from the water. Because this is Florida. Florida is a peninsula, as we said earlier, and it's covered on the sides. So another thing that people don't often talk about when they talk about shoreline processes is what changes, what can change the erosion rate. A couple things. One of those is the sea level changes. So sea level has fluctuated over time. Okay, fluctuated means it's gone up and down, up and down, up and down. There's no constant. Rises in sea level are often attributed to melting glaciers. So it's saying the more water that melts from the glaciers, the more the sea level is going to rise. And they also attribute part of the sea level of the glaciers melting to fossil fuels. Then you have tectonic plates can cause a change in sea level as well. Now that one on tectonic plates we'll get back to, because those people who oppose climate change use tectonic plates as an example of denying climate change and also that the sea level is fluctuating. All right, well, this is the end of the world as we know it, or the end of this lesson as we know it. If you have time, go back. I don't know if first and second period will have time to do that, to watch that video, but try to watch it tomorrow, if nothing else, on your own, if you don't get to it today. All right, get to work, guys. Have a great day.